Ever since mankind has stepped on the moon, its quest for space exploration has paced up, and now the next target appears to be the red planet. Yes, we're talking about Mars. But is there any evidence of life on Mars? Will NASA find anything supportive of life on Mars? These questions excite both scientists and the general public. Digging into these questions could require going underground on Mars. That's what the Mars Life Explorer (MLE) mission, a potential NASA mission, would do. Want to know more about this mission? Stick around and watch the complete video. Hello and welcome to Tipsy Alien, where we discuss the most mind-blowing facts about aliens, extraterrestrial life, and space exploration. Subscribe to our channel and press the bell icon so you don't miss future updates. Without further ado, let's get straight into this. The latest Planetary Science Decadal Survey, a report released in April this year by the United States National Academies of Sciences, Engineering, and Medicine, endorsed the Deep Dive MLE, which would focus on searching for signs of currently existing red planet life. Planetary Science Decadal Surveys identify the top research priorities for the next 10 years, and looking for life on Mars is on the top of that list. Mars Life Explorer should be the next priority medium-class mission for the Mars Exploration Program, following the peak spending phase of the Mars Sample Return mission, the report states. Everything we've learned about Mars over the last century suggests that the planet was once capable of hosting ecosystems, and that it may still be an incubator for microbial life today. Mars is the fourth planet away from the Sun, following the Earth. It's slightly larger than half the size of Earth, with gravity only 38% of our planet. It takes longer than Earth to complete one full orbit around the Sun, but it rotates at roughly the same rate. Because of this, a year on Mars lasts 687 Earth days, while a day on Mars is only 40 minutes longer than ours. Despite its smaller size, Mars's land area is roughly equivalent to the surface area of Earth's continents, implying that Mars has the same amount of habitable real estate as Earth. Unfortunately, the planet is now enveloped in a thin layer of carbon dioxide and cannot support earthly life forms. Methane gas appears in the atmosphere of this desiccated world regularly, and the soil contains toxic compounds. Although water exists on Mars, it is trapped in the planet's icy polar caps and buried beneath the Martian surface, possibly in abundance. The Mars Life Explorer would be capable of detecting signs of extant life in ice formations close to the red planet's surface if they exist. The lander, as planned, would drill into the ice, extract samples, and analyze them on the spot. MLE could be launched in the 2030s, land within a vertical meter of Martian mid-latitude ice, drill for samples up to 6.5 feet underground, and study those samples on site. NASA's Mars program has been a huge success. It's a scientific triumph, said Philip Christensen, a professor at Arizona State University's School of Earth and Space Exploration and co-chairman of the National Academy Steering Committee for the Decadal Survey. According to Christensen, the Decadal study recommended launching the MLE mission, which rose to the top when the panel reviewed mission concept studies. The Decadal Committee thought the mission made most sense, he said. I think looking at modern ice on Mars after sample return is a very logical thing to do, Christensen added. According to scientists, the MLE lander could work in tandem with the Sample Return Initiative, a joint NASA-European Space Agency campaign aimed at returning samples collected by NASA's Perseverance Mars rover to Earth in 2033. Amy Williams, an assistant professor of geological scientists at the University of Florida in Gainesville, is a key science advocate for MLE. According to Williams, NASA has come a long way since its first serious search for extant Mars life, conducted by the Viking 1 and Viking 2 landers in the late 1970s and early 1980s. We've invested in Mars exploration since the days of Viking, which has allowed us to build a robust understanding of the Martian environment, both past and present, Williams told Space.com. She cited NASA's Sojourner rover, which demonstrated in the 1990s that remote science could be conducted using a robotic wheeled vehicle. Then there were the Mars exploration rovers, Spirit and Opportunity, which looked for and discovered solid evidence of ancient water on Mars, according to Williams. The robot's descendants have kept the research moving forward. The Curiosity rover looked for and discovered evidence of habitable environments, with the core requirements for life as we know it: water, carbon, and a chemical energy source from metabolism, and now the Perseverance rover is looking for evidence of ancient life in the delta deposits of Jezero crater, she explained. According to Williams, NASA's Phoenix lander, which discovered water ice and perchlorates near the planet's North Pole, and the agency's Marsquake hunting InSight lander have also contributed significantly to our evolving understanding of Mars. Since Viking, we've made numerous discoveries on Earth and Mars that have informed our expectations and challenges for life beyond Earth. The ability to sequence microbial genetic material was not even a possibility until the 1980s, but it would be a powerful tool in the search for life beyond Earth, Williams stated. On Mars, we discovered that an uncommon salt, perchlorate, was present in sufficient abundance and physical distribution in the Martian soil to influence one of the methods we use to detect organic molecules, pyrolysis gas chromatography mass spectrometry, she added. According to Williams, we now have confirmation that the shallow, less than 6 centimeters subsurface environment can be surprisingly different from the surface rock, increasing our interest in probing deeper into the Martian subsurface. Finally, according to Williams, there is concern about how humans on Mars will affect the local environment, including the microbial environment. Of course, avoiding forward contamination of Mars is a huge priority, she said. However, sending a mission like MLE before the arrival of humans is preferred to increase our confidence in any and all of the mission's findings. Honeybee Robotics is in charge of the MLE's drill system based on the company's the Regolith and Ice Drill for Exploration of New Terrains design. Trident is an ice mining drill being developed for 2 NASA moon missions, the Volatiles Investigating Polar Exploration Rover and the Polar Resources Ice Mining Experiment. The MLE mission is intended to be completed in the mid-latitudes of Mars during the spring and summer. The technology is ready now, and presumably there will be technological and engineering developments of this one and other drill systems such that system improvements may be available by the time MLE launches in the late 2030s, Williams explained. Getting to underground ice is obviously critical for MLE. The story of ice on Mars has undoubtedly evolved over time. It's important to remember that we didn't always have confirmation of water ice in the Martian subsurface, Williams said. Those first images of Phoenix digging into the regolith and seeing ice sublimate were inspiring. Observations by NASA's Mars Reconnaissance Orbiter and the Thermal Emission Imaging System instrument on board the Mars Odyssey spacecraft have advanced scientists' understanding of the Mars water ice story. MRO, for example, carries a shallow subsurface radar instrument called SHARAD, provided by the Italian Space Agency. SHARAD scans the Mars landscape for a strong radar return wave. A strong rebound could indicate the presence of underground liquid or frozen water. We now have increased confidence that we can land a stationary spacecraft within 1 meter of the surface, Williams said. The beauty of mission concept studies like MLE, according to Williams, is that they are studies of a specific idea. There is ability to develop alternative landing sites to increase confidence in a specific landing site, as well as in the payload we send, she said, and to address the most fundamental question, are we alone in the universe? The answer to this question is not yet simple, but within this vast universe, we like to believe that we're not alone. There must be someone out there that is not a human. What do you think? Is there any life on Mars? Let us know in the comments section. If you liked the video, please click on the like button. Here are a couple more videos that might catch your interest. That's all for today. Please share this video with your family and friends. Thanks for watching.